So here's more about functions. We're looking at functions as graphs. We're going to talk about continuity and discrete. Okay, so a graph that's continuous basically means you could draw the line without lifting your pencil. Okay, whereas a graph that's discrete would not be the case. Okay, so if you look at this first graph here, this is actually the graph of an absolute value when you learn to graph it. This here would be continuous. Okay, that means all the points are connected, if you will. All right, whereas this graph here is just random dots, we would say this graph is discrete. Okay, so again, if the dots are connected, it's continuous. All right, if not, it's discrete. You can go through and figure out what the rest of these are. That's not very difficult to do. Okay, and now we get into some of these situations where we read a situation and we try to match it with a graph. Some of these are very confusing. Okay, so you really have to be careful and look very closely at what the graph is depicting. This graph is depicting speed and time. Okay, so that would mean increasing speed would be going this way, decreasing speed would be going that way. So if I read the first problem, Kiara walked up a hill at a steady pace. Once she reached the top, she ran down the hill. I know many of us would probably choose graph B because we're imagining walking up a hill, sprinting down a hill. Okay, that's not what's happening here though. The speed here is increasing. Well, she's not increasing her speed going up the hill. She's increasing her speed going down the hill. So this graph is actually the one that depicts the situation. She's walking at a steady pace, which means her speed's not changing. See how this line's not changing? Okay, and then when she runs down the hill, her speed is increasing. All right, so graph A would be the best option. Okay, so you really got to be careful here. A plane lands after a flight and comes to a stop to let the passengers off. Which graph represents the speed of the plane? Okay, so does the plane slow down gradually over time? Or does the plane flying at a constant speed and stop all of a sudden? Okay, now it's going to be graph B because a plane gradually decreases its speed as it's landing and comes to a stop. A plane doesn't fly at a consistent speed and all of a sudden just stop in midair and land. Okay, that's not how it works. Maybe a helicopter. All right, so I want you to go through each of these and see if you can match up the correct graph to the situation. And then comes the time to draw your own graph. So the number of customers at a restaurant depends on the time of day. Graph time on the x-axis and number of customers on the y-axis from 11 a.m. to 9 p.m. So if we start at 11 a.m., okay, and we go to 9 p.m., when is a restaurant going to be the busiest? Okay, and this is number of customers. Okay, so restaurants are going to be the busiest between 11 a.m. and probably about 1 p.m., okay, because they're eating lunch. So the number of customers increases, okay, during that time, okay, and then it starts to dwindle around 1 p.m. and probably goes pretty far down until you get to about what time? Maybe 4 p.m.? And then again, the number of customers is going to shoot up because people are coming for dinner. Okay, but then it's going to gradually come back down, all right, to 9 p.m. when they close and there's no customers. Okay, so we're trying to highlight those peak areas, right? This would be lunchtime, right? And this would be supper time. Okay, so you want to try to sketch a very basic graph, okay, for each of these situations. Okay, so, you know, a baby is born and grows up. Graph the time on the x-axis and the height on the y-axis. Okay, so when a baby's born, it's not 0, right? It's going to be a couple inches long when it's born, maybe like 20 couple inches, 2 feet or so. All right, and during the first years of life, that baby's going to grow pretty consistently. Now, if you're David, you know what I mean, that levels off at like, what, 4'6", okay? But, you know, other people can grow to be a little bit taller, but eventually you do reach your maximum height. So even like Mr. Warner, I'm not very tall, okay? And then I stay the same height for the rest of my life. All right, so that's what your graph would look like for something like that. Okay, now I want you to go ahead and draw a sketch for each of those and complete this worksheet for lesson 18.